All right, welcome to today's edition of Pipeline Things. Two topics on everybody's mind. Who's your ILI vendor and how is your fantasy football team doing? And maybe there's some correlation between the two of those or similarities. Maybe we can draw a metaphor between fantasy football and ILI vendors. You're going to have to pay attention to this episode to find out. Lots of hot takes from Bruce Nestleroth, a returning guest, and a little discussion on fantasy football. Thanks for joining us. Such a giraffe animal. All right. Welcome to this edition of Pipeline Things. That's actually take two on the intro because in the first intro, Chris fell into the table and broke multiple things. Literal proof of broken things. Evidence of carnage on Pipeline Things. So I am excited to be back this week. But before we get into this week, you're going to date the episode. And I know enough about you to know that I can't talk you out of something once you have it on your head, Chris, or on your mind. So
you're successful sometimes.
No, not really. No, not really. So I know what's on your mind because I'm the one that's probably partly responsible for introducing you to it like 4 years ago.
I think it's more like 5.
And that's fantasy football. So
yeah.
Chris, this is the opening week of fantasy football. What's on your mind?
Yeah. So it's a great question because it feels a lot like the topic for today's episode. So I'm in a situation, right, where I have to pick 3 players to be in my starting lineup. And 2 of them play tonight. And so out of the 3 that I have to pick, I have 4 legitimate contenders and all within like a 1.5 points of each other. 2 of them are established players that we know their talent and they're
veterans.
Yeah. Well, I guess you could call them veterans.
Yeah.
And two are rookies, but they're in really good matchups and in really good situations. High potential. And so I'm stuck. I'm not sure who I want to pick. And I have a timeline, like 2 of them play tonight. So I have to make my choice on who my starting lineup is going to be here pretty quick. And I felt like often we feel like these pressures are analogous to what we deal with and what we're going to talk about today on the episode.
Is it really? You really feel like that's analogous to MFL or ILI technology?
Of course it is. Which vendor do you pick? You know, I have to get it run by this date. Which tools are available?
Well, now that maybe, but I was thinking more like usually, you know, you have the vendor that you want to use, but it's like they're coming out with something new, right? Or maybe it's using the technology in a different way.
Is it a vendor or the technology? It's like, hey, we know we have to do a metal loss assessment. The line has had these 2 vendors in it before, and we're comfortable with either of them. But there's this other vendor that seems to be doing really good things. And I feel like I want to give them a try because I feel like I understand the integrity of my pipeline right now. And we know that if we look at KPIs, you could find a legitimate argument to bring them in. Either it's first run success or on-time reporting. You're like, well, this is where I get to with the fantasy football. It's like my 2 veterans should perform, but sometimes things happen that they didn't that day, and it's perfectly explainable. Sometimes you were supposed to get a first run success, and it doesn't happen, and they perfectly explain it.
Like let's flesh this out because I'm all about killing this analogy.
Oh.
Yeah. So I could see it. Like, I was going to say, but you already answered the question, which is when you have a proven veteran, you run the rookie against the proven veteran, and the veteran's your baseline, right? And then you evaluate the rookie as to whether or not he matches up against the veteran. But you can't do that in fantasy football. You can't. One or the other.
Yeah, because once the week is gone,
let's go ahead. I'm going to take this analogy a step further. My Grizzly veteran, Amari Cooper, just announced that he's retiring. So will you please extend that analogy to ILI? I mean, does this happen where it's like you contact a vendor and they're like, no, peace out, dude. We're out of the market.
Actually, I recently found out that there is a fleet of tools that recently got retired. And that wasn't in the last 24 hours, but it was within the last, call it 18 months.
Yeah, well, hopefully that doesn't happen to clients where they're like, yeah, I know we have that run schedule for you next week, but we're actually closing shop. We're done. So
no, maybe not the whole shop. But anyways, yeah, it's fantasy football is a fun time. There's wins and losses, and I feel again that's a whole lot like fantasy football from week to week sometimes.
Yeah. Well, mine's starting off. We'll see. I guess I'll lose our league.
So
now.
best of luck to all of you, best ballers, redrafts, dynasty leagues, all that fun stuff.
So on that note, we're bringing back a guest who was probably one of my favorite episodes. And I think the reason that I like this particular guest is, I mean, obviously, our guest is really well established in the industry, really recognized. You know, I think I actually sent an email to a client the other day who said, hey, somebody said this, and I literally copied and pasted the transcript from our previous episode into the email and said, yeah, this is what Bruce says. And I take what Bruce says against anyone else, hands down, but you can choose however you'd like. And so without further ado, that is our guest, Bruce. Welcome back to the show. Really glad to have you on.
Hi, thanks for having me again. I'm really looking forward to this. Would rather have been live in the same room as you guys because it gets a lot more energy that way, but not sure I want to be in Houston at this time of year. It's 70 degrees and sunny up here. I don't know what it's like down there.
We are in the middle of a cold front and it's 96.
Yeah.
So, I mean, you know.
And what he means by that is this morning when I was taking my kids to school, it was actually really nice out. There was a cool little breeze. For us Southerners, it was that nice humidity, not the sticky humidity. It was awesome. And then you walk outside at 3:00 and it's like, what happened?
Yeah, right. So Bruce, clearly you did not get enough punishment from us last time, or you enjoyed it so much that you couldn't resist. But the audience that doesn't, or if you're new to this episode or new to this guest, I would highly encourage you to go back and listen to the first episode to get a little bit of background on Bruce, hear where he came from. But since the last episode and today, Bruce, can you tell us a little bit about what have you been up to? What's Bruce doing these days?
Yeah, that kind of what I tell people. I'm easing into retirement. I probably only work a day or day and a half a week anymore. I kind of don't want to work that much anymore. I'm having getting in shape, trying to playing with the grandkid and going on vacations. Had a 3-week vacation in Europe. It's just a lot of fun stuff.
So is this work or vacation?
Oh, this is
fun.
This is fun. I don't count that.
Yeah.
There we go.
I'm not.
All right. Well,
I'm not billing.
We need to double check that, Mr. Producer. Make sure,
just in case.
So excellent. Well, then, hey, I'm excited to talk to you. I know Chris is. So, audience, get ready. This is probably going to be more of Chris talking than it is me talking, just because Chris gets really excited about this. So, Chris, you know what? For once, I'm going to turn it over to you and let you guide our return guest through the journey that is Pipeline Things.
Well, we will see how long that lasts before you take the reins. So, Bruce, obviously with your background, if anybody who didn't listen to your first time on the podcast, your background has a heavy magnetic-based ILI technology component to your experience. And so recently, if you scroll through LinkedIn for longer than 10 seconds, you're likely going to see some kind of post related to either an MFL tool or any other magnetic-based technology. And so we thought it'd be fun to bring you back on and just ask you a series of questions where we'd like to get your hot takes.
Okay.
Really, that's the idea.
Wait, does Bruce know what a hot take is? Bruce, that's a new term. Like, I just learned what hot take means. So I feel like Chris is throwing this term. Do you know what hot take means?
Maybe not in your context.
Go for it. See, you couldn't be quiet. Go for it.
Yeah, no. So hot take is what the new kids on the block are using, like my son and all of my high school students, right? Yeah, there you go. So hot take means I'm going to take a take that's usually opposite or likely to draw a lot of fire or criticism for what's said, right? So I don't want to give a hot take on this episode because I'd inevitably insult somebody, but I'm trying to think.
Yeah, don't do that. It will come. It will come. Don't worry.
I'm not afraid to get in trouble.
Well, there we go. Right.
My very first paper I gave back in I think it was 91 on MFL technology. They asked me what is your definition of a high resolution tool was, and I thought for about 3 seconds. It was after a paper, and I go, well, that depends on the smallest defect you need to size.
Yeah.
And it's a perfectly accurate answer. And
yes, it is. 34 years later.
Joe Caldwell, I don't know if you remember him. Joe Caldwell is an old timer. He goes,
no, sir.
That is an absolutely unacceptable answer.
but
Okay.
true answer.
Yeah.
Okay. So
Well-
so that's a hot take.
Yeah, I mean, it could be if what they needed was an absolute size, for sure.
So the idea is, Bruce, what I'd like to achieve with this episode is to get your opinions on things and share some of your experiences, such that our audience, as they're flipping through LinkedIn, or they're looking at a proposal, or they're sitting in a technology presentation, they have a basis to determine if they feel like they agree with you or if they disagree. And I think that's important, right? Because that's when people start investigating what they believe and they start learning, right? And so that's why I feel like hot takes are important.
Yeah.
Not so much to convince people to agree with you, but to rather to draw a line in the sand and see where people fall, if that makes sense. And so to get into it, if you wouldn't mind, we talked about this a little bit last time. How would you describe the ILI systems that leverage high field and low field technologies? Not necessarily residuals, right? But this idea of, I have a calibrated high field technology, I have a calibrated low field technology. How would you describe ways that those technologies could be used, and any personal experiences that you have with them?
Yeah, sure. I mean, when I started in the business, what is considered low field now was actually high field. That was as good as you could. The magnets weren't that strong, and so, but what the industry has done, and for good reason, is that they went to higher and higher magnetic fields, because the magnets kept getting stronger. Because what that does is make all pipe look the same. In other words, it makes the magnetic properties of the steel all the same. And then, but if you go to low fields, now all these the magnetic properties are different. And if you have some kind of metallurgical variation in your steel, you're going to be able to see that. If that can come from mechanical damage, that can come from hard spots, or all that kind of thing can change the magnetic properties of the steel. And so when you have these what is so-called low field, or even a residual field, the metallurgical changes give you a different signal. And so you can actually see things that aren't metal loss. You can see mechanical damage. You can see hard spots and those types of things. So it's getting back to what you could see. Old MFL tools saw everything, and that was part of the problem. Is they used to get a lot of false calls. When they're in the 1970s and 1980s, they get a lot of false calls because they were seeing things that were just metallurgical changes.
Yeah, because they weren't saturating the wall thickness.
They weren't saturating it to the level they do it now. So, but on the other hand, some of that, old signals were important. It might be mechanical damage. It might be a hard spot. So, those are things that you got to find.
Yeah. So it's fair to say that part of the evolution of, I guess, MFL technology, to be clear, right? Not just a magnetic based tool, but MFL technology, is that the biggest change is possibly towards POI, right? Because they weren't properly saturating lines there. You'd get an indication, but you weren't sure what it was. Now, by using these permanent magnets that we have, saturating the material, we're saying, hey, it gives us a lot better view of when we see leakage. Because there's so much saturation, it's most likely due to some kind of volumetric metal loss.
Yeah.
And so that's what's driving the indication.
Do you ever get and now when you look at a log, do you ever get a call that's called metal in close proximity, or metal in the backfill?
Yeah.
Yes.
That doesn't show up anymore. In the old days, that was a common call.
Yeah.
It's just one of those things. They've gotten rid of those things, but sometimes that could be important.
Yeah, so I'm curious if we could take advantage of your experience a little bit. So, as part of the failure files, we went over an incident from 2019, the Danville, Kentucky failure, the hard spot failure.
Okay.
And just a little bit of a recap, right? So at the time, Tuboscope had a hard spot tool, and they deployed that tool, call it circa 2004.
Okay.
Right? And it only called a certain number of features. And then they reran it in 2011, and after that run again, only a nominal amount of features called. Fast forward, failure happens in 2019. The data is reevaluated, and now instead of finding something on the order of magnitude of a couple of tens of features, now in the hundreds of features. What's your take on that, right? I mean, the data was there. That doesn't seem like it was a magnetic improvement, right? Because they're still looking at historical magnetic data. Now it seems more algorithmic or experience.
Well, was the tools had changed by then, didn't it?
That's the question, right? So again, I wasn't around back then. So from 2004 to 2011.
2004 to 2011, it did change. I was working on a project for, and that was when we were developing the dual field MFL technology. And I'll take, and so we started doing the technology transfer in 2005, and Tuboscope and Rosen and TDW were participants in that project. And we started providing information in there. So at that point, it's very well good chance that the 2004 tool, now I'm going to take a step way back, is the best hard spot detection tool. And you mentioned Tuboscope, and that's a company that isn't around anymore. And so, but they were the first pigging company. They were from the United States. And everybody's going to say they had a couple on it, but they were really pretty big news in the 1960s and 70s. And they had a very odd implementation. It was an electromagnet versus a permanent magnet tool. And the odd thing about that tool was it was great at hard spots. It would run through they run the magnet the first time through with the magnets on, and then run it through a second time with the magnets off. And the way it left the residual field, it left it at a really high level compared to a permanent magnet tool. I've got a paper on this on why that's true, but we won't get into that. But just trust me, it does give you a very strong field. And what it did is it was really good at hard spots. But running a tool with an electromagnet just wasn't practical. So when the permanent magnets got strong, that tool got shelved. That's where it all went. So, but the new tools really don't produce as good an information as that old Tuboscope tool. And then you have now going forward. What everybody did is they still used the basic concept that the Tuboscope did. It was basically look at the high field, magnetize the pipe, and then look with the trailing set of sensors for residual field. And that's what they did in 2004. And they found it will find some features. And my usual statement is if you find a few features with a residual field tool, I think you should run a dual field tool because you'll find more. That's basically what you came up with, I think.
What's the from a tool perspective? Can you help us understand the difference between? I mean, what is the actual difference between a residual field and a calibrated low field, right? And maybe the advantages there.
So a residual field just means you magnetize the pipe, and then maybe because you have a multi-body pig. And so maybe 3 to 6 feet behind the magnetizer, you run another set of sensors. And everybody knows, especially your welders, know that there is magnetic field left in the pipe after you do an MFL run. Once they try to run, when they try to weld, that's can be a mess of a time. And so, there's always magnetic field left. And with hard spots or cold working, if you have some kind of mechanical damage that cold works it, what it does is it just changes the amount of flux that the pipe holds. It's called retentivity. It's a big word, but and it just tells you how much residual magnetism is left in there. And so hardness, if it's hard, it's magnetically hard. It holds more material. A magnet is a very magnetically hard material. It holds a lot of magnetism. Harder steels hold more magnetism than soft steels. You want soft steels. You don't want something brittle and hard. So that's what you get. So when you go through the residual, it measures it, you magnetize it, and then at the end of this thing, it's left with a little bit, but it's usually something that's on the order of 10 to 20% of the original field, not much, and of the magnetizing field, and you're left with a signal that's small. If you have an active field going behind, but it's in the low area, you're still in the area where you're sensitive to those magnetic changes, why you had all those false indications, why you had those metals in close proximities, why do you had all these problems you had in the 1970s and 80s. That's where you're operating, but you go, oh, there is something there, and it is repeatable. So that's what you're doing. You're just coming back with something where you got a good control of it. Whereas the other one is kind of an open loop. Yeah, you'll see a few things, but it's going to be such a small signal that it's going to be hard to detect all of them.
Yeah. So then it sounds like the take is, if you were using a residual field, then you're probably finding the more significant or gross features because they're retaining more magnetism. So you might miss other relevant ones, but that's where calibrated low field came in. So it gives you visibility to some of the complementary features that maybe the residual field couldn't see. Yeah. So it's a push towards a POD of 90%, since that's our benchmark in the industry.
It's what you're trying for, 90% of what? I got to ask you something, and this is always the hard question. What is a hard spot? I mean, once you get down there, I get to I'm an ILI guy, and you're always going to be picking on ILI, and I think they do a pretty good job but the guys, once you get down to mechanics guys, they can't decide, what's a hard spot that I need to find? I mean, the API definition of a hard spot, if you had that in your pipeline, it would already have found you.
Yeah. Well, fortunately for us, FIMS has drawn that line in the sand with their advisory bulletin. So that's helpful, right? So if anything, it gives us a line in the sand for reporting thresholds, right? So, if you've ever talked to an ILI vendor, a lot of times when you ask them what their capabilities are, they'll reply with, "Don't worry about my capabilities. Tell me what the ask is, and I'll tell you if I can do it." Right? So at least now we have a line in the sand that we can say, what is our probability detection for features that have these attributes? And so fortunately, FIMS has kind of helped nudge us in defining what that may be.
I guess I have to go read up on that one. I'm a little behind the times there.
No, it's all good. Rhett, anything on high field, low field, hard spots?
No, I do have questions on some things that Bruce said, but I think the second part of this episode, we're going to take a break real quick, audience, because when we come back, we're going to shift directions and talk a little bit more about complex corrosion and maybe different burst pressure prediction models and get Bruce's take on those. And I got some follow-up questions on that, but hang around and we'll be right back in just a moment. That was actually terrible. Nobody knows what you were trying to do, but
everybody knows that's the NFL theme song,
Chris,
theme.
It's probably the first part of this episode is probably the least I've ever talked on any episode. How did it feel to lead the show?
I'm not
audience. You judge.
It was a lot less stressful. That's for sure.
Was it really? I don't know how to take that. I find that mildly offensive, but the audience can judge. We get enough feedback. Maybe we'll turn you over into the lead host.
No, we're not doing that.
Hey, Bruce, I had one question that I wanted to follow up because you made a statement earlier, which is sensors just keep getting smaller and smaller, and you were in your hot take thing. You were asked the question in a publication, which is how small is high resolution, and it got me thinking. It feels like the move in MFL tools, certainly over the last decade, has been smaller and smaller sensors. And
ultra.
It seems like, what's that?
Ultra technology.
Ultra. Yeah, I mean, ultra. I don't know what we'll call the next one. I mean, that's why I said I feel like eventually it'll be nanotechnology is what it'll be.
Well, there's a micron right now.
Well, I know, and the only thing smaller than that's nano, and I don't know if we have anything smaller than nano yet. I mean, maybe quantum, but it doesn't feel right. So, Bruce, it got me thinking, since you know it, is there a practical limit? Like, is there a ceiling or a floor, I guess, below which you'd say, like, look, once you get below a sensor size of X, practically it's impossible for some reason or other, or are there theoretical limits?
And specifically Hall effect sensors, right? So not just any magnetic-based technology. We're talking about Hall effect sensors.
Well, Hall effect sensors are the only ones that can keep getting smaller and smaller. The only other technology used on MFL tools are coils, and you can't, winding a coil on something that's, getting it down to, that does become, wire gauge and all that kind of stuff. That's just impossible. But Hall effect sensors is a semiconductor device, and semiconductors you can keep making smaller and smaller, and you get finer and finer resolution. And I do think that the ultra tools do give a step an advantage over the traditional tools that they were before that, which were on the order of probably 3 millimeters or 1/8 of an inch or 1/4 of an inch type of thing. Those are pretty good resolution, but I think that the finer resolution that you get with these new tools is a function. But you're starting to get down to things where corrosion is still things the size of your fingers. Even a pinhole. A pinhole is something that's 4/10 of an inch in diameter. I mean, your pinky can fit in that. And so if you have, let's say, 10 measurements across there, 40 thousandths of an inch, that's a millimeter. That's perfectly fine. Even 5 measurements across that. That's about where you're getting to. So you're getting close to, you need on the order of between 5 and 10 measurements for the dimension of the defect that you need the size. Otherwise,
which sounds great, right? I mean, saying an ultra tool with 2 millimeter sensor spacing is pretty reasonable these days.
Yeah,
80 thousandths,
and 2 millimeters is across a defect. It's a pinhole, which is 10 millimeters. That's okay. But if you're trying to size something that's 2 millimeters across, you're not going to size it. I still stick with that. It depends on the smallest defect you need to find size.
And POF only.
It is what it is.
And today our standard is POF, right? Which gets down to 1A, 1A, or sub 1A, 1A, which would be 10 millimeters by 10 millimeters for pinhole.
Right.
So
now.
I was going to say that brings us kind of to our next conversation, and I didn't want to transition without you. But
the other side of things is, and I guess before you get there, I did want to say one more thing. We're going to change subject before we get there. The end goal, though, is that over general corrosion, you're still not going to get much. You're not going to get better than a depth and a length. You're not going to get the river bottom as you go through the corrosion.
And see, but that you went to the next. That was where I was going next, Bruce. Is I feel like. No, it's fine.
Good.
I mean, let's go ahead and just open up the can of worms. You're probably going to give hot takes here. I don't think you have to go further than LinkedIn to look at, honestly, there are multiple vendors out there. And I think the claim persists that it's sensor size or other things that lead to the ability to handle complex corrosion and produce river bottom profiles. And I feel like, again, one of the central, maybe it's just clever marketing, but one of the central claims is that the sensor sizes now are small enough such that, yes, 20 years ago you couldn't get a river bottom, but now you can get a river bottom profile because the Hall effect sensors are small enough, the resolution is great enough.
Sampling rate.
Right. It's like we went from a traditional TV with 4:3 ratio to now we're in HDR, and now we're in 8K. Right. And with 8K, I can actually see the stitching on the football as the wide receiver drops it on Chris's fantasy league. So what say you, Bruce?
You're still stuck with something that is pretty foggy with an MFL signal. It's not going to give you, it's not a direct measurement. It's an indirect measurement. It's more of a shadow technique. And so what you're going to get is you're going to get piecewise river bottoms. No matter how you do that, you're going to get, if you have a pit in one area and another pit in another area, you're going to get those as peaks, and you're going to get, but you're not going to know how deep the what the area is in between those pits. You're not going to tell you if did that go to full wall thickness, or did that go to 20%, or did that go to 40%. You're not going to know the valleys, how deep the valleys are. It's not going to be a true river bottom. It might tell you where some peaks are, and it can tell you, where the overall length is and where those peaks are located. But that's not river bottom.
So let me ask this a different way.
Wait. Why is that not river bottom? I just want to, and that's because you're saying that you can get the individual peaks, but you can't get what's in between the peaks.
Right. Well, that's what RSTRENG did. When RSTRENG, took whatever decided you want to make your measurements, it was the highest amplitude, and let's say every quarter of an inch down the pipe or every half an inch down the pipe, and you found the biggest, the deepest point on every one of those rows in an Excel spreadsheet. Well, excuse me, a Lotus 123 spreadsheet.
Lotus.
That was what it was originally written in. And so when you're going through there, and then it just sums, and then it sums up those depths. Or now, okay, you're just saying, well, I'm going to give you the peak here, and then the peak here, and the peak there, and the peak as you go. But that has no information about in between. So that's not river bottom.
Yeah. So another way to think about it is comparing these ultra high resolution MFL tools with, let's just call it for now, 2 millimeter sensor sizing and really high sampling rates. That if I were to take a laser scan of a feature, a complex corrosion feature, not this nice, pretty manufactured flaw or series of manufactured flaws, but let's call something where we'd actually want to use RSTRENG, right? Let's call it 4 feet long by 50% of circumference of the pipe. This is substantial. So you're saying if I laser scan that and I have, let's call it 2 millimeter by 2 millimeter grids from the laser scan, that it's not practical to say that I would be able to extract the same location and number of true deep pits from the MFL data that I would find in the laser scan data because of the physics behind the measurement principle of how the sensors ride along the ID, even at the resolution and sampling rate.
It's not going to be the same picture. It's not going to be the same picture to get exactly the same measurement that you have out of a true RSTRENG micrometer depth measurement. It's just not going to be.
Well, let me ask you. I want to ask you two questions. Opportunities for hot takes, Bruce, if you so choose. Why do you believe there is so much confusion? Right? Maybe I'm assuming. No. Maybe I am presuming.
Yeah.
And maybe Bruce would reject the hypothesis by my confusion. So let me start over. Bruce, I believe our industry is confused about this.
Confused or just don't understand?
No, I think confused. I think confused. And if Bruce rejects my hypothesis, and he can choose not to answer the question, I think most vendors, by client request, have a column in their spreadsheet that has P-burst, effective area. That's what it's titled.
Yes, it does.
Yeah.
Everyone has that.
If what you're saying is true, why, number one, why are operators asking for it? Why are vendors providing it?
Well, vendors provide it because operators ask for it.
Hey, how many times have we heard this, Rhett? How many times we're in a meeting and we say, what are your capabilities? And they say, tell me what you want and we'll figure it out.
I feel like
they're trying their best. I think the vendors try to do that, and they're trying to give you a value out there. And their competitors say no, and their competitors say the same thing. But they all know that it's not true river bottom, and and it's never been shown that or actually proven that it has. It's always there's a few papers that are demonstrated, but it's never been hardcore shown that it gives you the same value. It's probably conservative.
And I agree with you. I'm not casting shade on the vendors. Let me be quite clear if the vendors are listening to this episode. I do believe that the vendor's default response is yes, and I can understand that. So maybe I'll just ask it quite in a different way. Why as an industry is that understanding not more clear among operators as to the limitations of using MFL with RSTRENG? Have we not done a good job of education? Do you think it got muddied somewhere? Is it do you think we dropped the ball? I'm just curious. Is it a
dirty secret? We just don't like talking about it because it gives us a larger burst pressure, and we like that, and we know there's other conservatives built in, so we just don't talk about it?
Or is it because like UT came in and UT
be more reasonable
does
at it?
have the ability to do it if it's taken point by point measurements? I was just curious. I wasn't looking to cast shade, just curious.
I don't understand the problem either. I still teach this, and I've had people challenge me, and I'm sticking to my guns. And if somebody can show me that they are actually getting true river bottom and show me how that's being done, I'm all for it. But if the other way to look at these things is you look at the papers where they're trying to do magnetic inversion, where they actually take a 3D field, take all three magnetic sensors, and try to invert that into a geometry. And they're not all that successful doing that.
Yeah.
Every paper I've ever seen on that never does that. And if you can't get the picture, you can't get the river bottom.
So I did a little bit of research on this in my earlier days of being an integrity engineer, like when I first started out. And I have assumptions, and I'm calling them assumptions. So audience, if you have please share. And I truly mean this. If there is literature that is published that contradicts what I'm about to say or fills the gap, please share with us. So if I'm not mistaken, I may get the year off or so. I remember when I was doing homework back in like 2008, 2009, I found an IPC paper by PII. I just call it 2004 was around when it was published, and they introduced the concept of LAPA. And
Right.
So my take on it then was that basically they would take the box feature dimensions and they would cascade them down into river bottom profile. And that was strictly based on interaction criteria and what the ILI tool was able to see. And they collaborated with a couple of operators and showed that approach could be conservative, like it could be used. And so they would use the sequence of analysis that effective area deploys against the profiles generated through the boxes that the ILI features called. And that process was not called effective area or RSTRENG according to B31G. It was a process that I understand was branded as LAPA. And so I'm not saying that was validated, and I am not saying that is a technically feasible approach. All I'm saying is that was a paper that I found that was intentional about saying this is how we are deploying this is our application of an effective area type approach using MFL data. And
that's the paper I remember. And when I present my explanation of can MFL do RSTRENG, I say that paper demonstrated that this technique is where you basically are just using stepwise over each individual pits and going that way. I kind of use them. It looks like a Minecraft kind of boxy thing. That's kind of how it looks. It's not smooth. It's step all the way through the whole thing. But it's not been validated. It's been demonstrated, and demonstration is not validation.
Yeah, I agree with you on that take. Now, what I would say is what we have seen though is so once these boxes are in place, I have seen how these boxes are then sliced into different axial dimensions, right? So let's say they'll take that and slice it into 1 millimeter by 1 millimeter slices and run the effective area calculations on that. So that it models effective area, but again, the river bottom profile itself is based on boxes.
But it's still
a step,
plateaus.
That's exactly right.
Going through the entire complex corrosion, and that's not my understanding of river bottom.
Yeah. Well, I guess what I would ask the audience is, again, guys, we're not trying to be, confrontational or contrarian. I think the ask specifically is not just work that's been done or examples of how it's implemented or its application. I think what we're curious about is there any literature that validates the approach of using MFL technology for computing effective area burst pressure calculations, and that it's conservative? And I'm aware of the Advanica report, and the Advanica report clearly states that B31 and modified B31 were looked at for MFL data, but it clearly does not say RSTRENG based calculations, and I think that was left out on purpose.
I hate to be the bearer of circular logic, but you guys, those were with older sensors, and the new sensors are smaller.
And they're better. And we have better algorithms.
Well, Chris, I do want to challenge you a bit on that. And Bruce,
Yeah.
maybe you have an opinion.
Yeah.
Because you were asking about literature. There's been a lot of published literature on the P-squared approach, which uses RSTRENG as its basis and was developed, as I understand, with ILI as a basis. So I think the first thing that hopefully a listener would come back with is, hey, look at all the publications on the P-squared approach, right? Which does, as I understand, show that it has some conservatism. And as I understand, was developed with ILI in mind. Bruce, you probably are closer to this than either of us. Do you have some opinions or thoughts that you can share on that?
Well, I just think that P squared is just a more practical implementation of RSTRENG, and it, you know, when you know when you only have an IBM PC with a 5.25 floppy disk to be able to run your calculations, you're not going to be able to find the optimal path through all these boxes. You're just going to say, well, I'm just going to take the deepest one in my row and say that's the best I can do. It's not going to be able to do those kind of calculations. What you can do today is you can do better calculations. But still, when you look at the MFL data that they have for when they did the validation, again, it was still plateaus through the deepest pits in that area. It wasn't looking at the the laser data or the high resolution images.
Yeah. So I was kind of excited when I saw the P squared work happening back in the day. Obviously, I don't think either one of us were involved. And obviously, Bruce, I thought I saw you on a couple of papers, but
I was fortunate enough. There's a lot of mechanical guys on that committee who was doing the review. I was the ILI guy, so mechanically, they were looking at it, but I was trying to evaluate it there, and I thought it looked like, it was good. It was better than RSTRENG because it did find a plausible profile. I always thought it was kind of bad that if you have a corrosion pit at the 11 o'clock position, another one at 1, and back at 11 and back at 1, and going that's the deepest point going like that. That fracture surface isn't going to run back and forth. It's going to find a path through there. It's got to be plausible.
Yeah.
And that makes a whole lot of sense to me. But you still were doing the plateaus for doing the MFL data. Now they had a couple dozen burst tests, as I remember, or something that they did, but it wasn't which is great, but it wasn't it wasn't a lot of proof, and it was just a few different diameters, and it's expensive to validate something. That's the difficulty.
Yeah. Well, one of the papers that I really appreciated that gave me hope of P square, and I mean that I'm very high on P square based approach because and again it's one piece of evidence, not enough to say it's validated for sure, but it's going in the right direction in my opinion. So I think it was 2020 TC Energy published a paper at IPC where they basically took, I think it was 154 immediate calls that were a result of RSTRENG in an MFL-based ILI report. And of those 154 immediates, they were able to get, I think it was 84 laser scan data for 84 features that were called as immediates by RSTRENG. And of those 84, when they then ran the ILI data through P square, only 15 of them were required immediates. And so what I'm getting to here is saying that type of analysis, that type of data where they're very transparent about the process, right? I had an ILI report. It had this many features that were called as immediates through RSTRENG. We went and we did field excavations. We collected laser data, and then we ran P squared, and we do this transparent comparison of them, and they walk through how they're doing P square and how explicitly how ILI data was used, specifically MFL data. I think that starts raising the bar of confidence, right? And my position has always just been, I'm not saying that IMFL data can't be used for RSTRENG. I'm just saying, show me how it's done and show me why we should trust it. And I think that some of the modern literature that we're seeing around P squared starts raising that bar of confidence, and it starts presenting information in a way that I think we could start buying into it. And back to Rhett's point, I think that you're right. They do speak to RSTRENG's performance in those papers, right? And so by proxy, you also begin to gain confidence in the approach of RSTRENG. What I would say is, though, that is unique to potentially either that operator's process or that's vendor's process, right? So just be real careful about taking someone else's work and adopting it in your processes without understanding what those essential variables were in said process.
I agree 100%, but it is probably some of the best validation of MFL being able to use the piecewise plateau method of analyzing MFL data into a RSTRENG type calculation, that it does actually work. And it does it does. That's probably the closest we've gotten to validation for RSTRENG. And then it takes it the next step and says, and we can do a little better if we do it with LAPA. And I agree. It's good stuff. It's just, again, what you said, make sure your essential variables are the same. Make sure your corrosion looks like their corrosion. If it, there's a very, corrosion on one person's pipeline and corrosion on another one, there are often different morphologies with those. And that can make a difference on whether this technique will work until you've checked it on a good variety of things.
For me, it's also the ILI system, right? Like MFL is not MFL, right? I mean, one vendor's tool is not the other vendor's tool. I mean, and I think the ILI vendors do a really good job of staying competitive, and operators need to keep running them so that they keep innovating and keep challenging each other for market share, because that's how we get better tools and better solutions. But I do think people need to be careful about how one MFL service provider will translate Hall effect sensor voltages into some kind of characteristic data of a metal loss feature. Saying that you meet a template doesn't necessarily mean that the data analysis and the export of that data into your template are the same. They're not always apples to apples.
Yep. And you have to, I don't think that any of the Trans-Canada work that you were talking about there was done with any of the Ultra tools. It'd be really interesting to see where that goes.
Yeah, that's a good point. Yeah, I'm not aware of that either.
It wasn't around then. It was just their data collection was in the late 2010s, and that Ultra tools that weren't.
So if we think cup half full, that means it only could be better now.
Yeah.
So, Bruce,
maybe.
I want to say thanks for joining us again. It's been a lot of fun. We have more topics that we could cover, which also makes me hope that, again, in your retirement and your 1.5 days a week of working, that we managed to find time to chat with you again in the future. But definitely enjoy having you on. And
hey, it's always great.
Yeah. And for our audience, pay attention to this season, because you will get updates on how Chris and I fared in fantasy football. And hopefully it's better than the broken pieces of Miss Producer's equipment that I see on the floor over there from the original. I can't say
this. Rhett and I are in a best ball fantasy football league together. And I would be curious who y'all think is going to win out of the both of us. Not just against each other, but who's going to end up higher ranked at the end of the year. I think everybody knows the answer.
Stay tuned to find out. Thank you guys for joining us on this edition of Pipeline Things. We'll be back in a couple of weeks to talk with you guys again. Cheers. All right, credit for this episode. Thank you for Sarah Etier for being executive producer, my glorious co-host, Christopher De Leon, our returning guest, Bruce Nestleroth, and to the Work Lodge for letting us use this space for the production. This episode was written by no one. It was made up on the spot. Thank you.